Okay, multiplicative relationships. We're going to tie it all together with an equation, description, graph, and a table. So let's start off with the description. The cost of an ice cream cone is $1.50. So one ice cream cone is $1.50. I'm going to go ahead and graph this. One ice cream cone is $1.50. So that means that two ice cream cones would be $3. Three would be $4.50. Four would be $6. And I'm going to keep going with my graph. Okay, now I'm going to fill out my table. So my X, which is number of ice cream cones, right here, that's what's going to go on the table for X. So number of ice cream. I'm going to put IC. Okay, and then my Y, let me put that in green. My Y is the total cost. So that's going to be over here, total, and I'm going to put the money sign. Okay, I'm going to go ahead and fill out my table based off of this graph. So one ice cream cone is going to cost $1.50. Okay, two will cost $3. Three will cost $4.50. And I'm just looking at this graph to give me these numbers. Okay. 4 ice cream cones will cost $6. 5 cones would cost me $7.50. And then 6 will cost $9. Okay, so when we write an equation from this table and this graph, remember I showed you on the last one that you just bring down your X. Oh, sorry, I forgot to talk about the relationship between these two. So we know that it's multiplicative. How do you go from 1 to 150? You multiply by 150. 1 times 150 is going to be 150, right? 2 times 150, $1.50 times 2, which is $1.50 plus $1.50, that gives you $3. So this rule is applying for every single thing. Okay, so when we write our equation, we just bring down our X. We bring down that same rule that's happening times $1.50 and then equals Y. But when we write our equation, remember it's Y equals KX. So we want to write it using this. So Y equals K, which is the constant rate of change, which is the $1.50, which is 1.5, and then you put your X. So this 1.5 just replaces the K, which is the constant rate of change or the slope. Now, what I want you to do is, looking at these tables and graphs, I want you to figure out and circle the ones that are multiplicative. So you're going to have to go and figure out what's happening in each table. The graphs are easy because remember, multiplicative graphs go through the origin. Okay, remember the origin is 0, 0. So pretend as if this is a full graph. Pretend this is a full graph. Does it go through the origin, which is 0, 0? And then the tables, you'll have to see what's happening. What's the relationship? How are we going from 20 to 25? Is there anything we can multiply by? No, I can't think of anything, but I know that I can add 5. 40, same thing, plus 5. 60 to 65, again, plus 5. If you're adding, that's additive. I want you to find the ones that are multiplicative. Okay, going to additive relationships. Let's look at our description. The industrial tech teacher told his class to add 2 inches to the length of each student's project. Okay, so 2 inches to every single project. So for the length of the project, so when we figure out our graph, the length of the project, if the length is 1, we're going to add 2. So I'm going to fill out the table first because it's a little bit easier for me. Again, my X, right, is the, I meant to use the highlighter, is the length of the project. Okay, this is length. That's our X, and then our Y is going to be total length. Okay, so if my length of my project is 1 inch and it says to add 2 inches to the length, I'm going to add 2. 1 plus 2 equals 3. Okay, if my length is 2 inches and I add 2 again, it's going to be 2 plus 2 is 4. Same for 3. If I'm adding 2, the total length will be 5 plus 5. 4 plus 5 equals 9. Oops, plus 5. I'm sorry. It should be plus 2. What am I thinking? 4 plus 2 equals 6. And then 5 plus 2 equals 7. Okay, so I'm going to go ahead and graph these. Remember, these are my ordered pairs. So 1, if it's 1, I should be at 3. If my project is 2, it's going to be at 4. 3 will be at 5. 4 will be at 6. 5 will be at 7. 6 will be at 8, etc., etc. Okay, I'm not going to finish graphing, but I'm going to go ahead and I'm going to draw my graph. Okay, now when we write our equation, remember we bring down our x, we bring down our rule, which is plus 2, and that equals y. So when we write this, remember the equation is in y equals x plus b. So when we write the equation, y equals x plus 2. And remember, you'll learn this next year, but b tells us that's where it crosses the y-axis. And looky here, it crosses right here at the 2. So again, you'll need to figure out and circle all of the additive graphs and tables.